Good afternoon. Welcome to today's webinar. We are going to talk about having what it takes to oversee a software project. And I will make the assertion that because you are here, you do have what it takes to oversee a software project. And I'm going to talk about how. I'm going to talk about how to be great at doing just that, you are whether you are leading a single team in the team, whether you're managing one team, or whether you have groups upon groups of software teams. Um, I'm going to make the assertion that you do have what it takes to do this, and I'm going to talk about how to be really great at that. Um, and we all know the significant budget necessary to operate software development teams. But at the same time, how much revenue that companies are able to capture by doing that. So it's a great return on investment as long as the software team can deliver on what's necessary. Um, so I'm excited for today's webinar. We have a really, really great crowd. It looks like we have all levels of software leadership represented here. And so thank you all for coming. Um, we have groups directly on the Zoom webinar as well as LinkedIn Live, which is a great avenue there, live streaming on both different places. And so um, let's dive into it. Um, so a little bit about ClearMeasure. We are a full service software architecture and engineering firm that serves companies that are building mission critical software software systems using Microsoft technologies. And we go very, very deep there. And our goal is that not only your software, but your software engineering capability as an organization is world class. And so if you are building or running, expanding, changing a software system using Microsoft technologies, we want to help you do a really good job with that. Whether you need some help, actually developing features or moving to Azure or automating some things or improving the quality control, automated testing, continuous integration, continuous delivery, any of the software engineering practices, we would love to we'd love to contribute wherever, including even being a third-party inspector if you have hired an outside party to build the software for you. We love making sure that whoever you hire to build a piece of software does a really good job. And so being a third-party inspector or outside assessor is also one of the things that we do. A little bit about me. My name, again, is Jeffrey Palermo, and I'm a chief architect here at ClearMeasure, and my main hobby is dirt bike enduro racing, a little bit of light ranching where I can, and I'm not terribly fast at the dirt bikes, but it's fun kind of riding mid-pack. My latest book that's been out for about 5 years now is .NET DevOps for Azure. And if you are interested in a free electronic copy of that book, then you can just send me an email at the email address right there on the screen, and I'd be perfectly happy to have that sent for you. So that's an offer that you can do. You can also get it anywhere books are sold. Um, As we go along, I'll talk about a few resources that we have that are a part of the ClearMeasure way. And you can go to our website, clearmeasure.com, to find all of those things. But we have a core belief that when equipped and trained properly, we believe that every software team can be world class. And so the ClearMeasure way simplifies and synthesizes known practices in a manner that any software team can implement. And the aspect of it that we're talking about today is being an effective leader of a software team. And so we're not going to go deep into engineering practices. We're going to go deep in leadership today. Another avenue that you may be interested in if you are a technical leader of a software team versus on the management side is a software architect forum. We do those monthly for other software architects who are leading software teams from a technical aspect. We also have a software executive leadership forum for for VPs of engineering and CTOs. You can also find that at clearmeasure.com/forums. All right, I'm going to start today by doing a little review. Well, going way back to 2001. And in today's day and age, Agile is pretty old from a terminology perspective. You might say, "Oh, nothing new." Oh yeah, Agile's been around for forever. Oh yeah, everybody does Agile. Agile's the normal way to do things, and Agile was very much a reaction against what was normal software process going into the late 1990s and kind of what happened through the web boom of 1990 to 2001. Um, and it was a reaction against really long development cycles and batching up, you know, weeks and months of talking about software, and then weeks and months of designing wireframes and documents, and then weeks and months of coding, and then weeks and months of testing. And it was normal to talk about that we were going to have a software release out sometime next year. And, that was rightly called out as insanity, and that we have to have working software very, very frequently. And so now, having working software more frequently is pretty normal, and having weekly and monthly releases is very normal. And of course, high performing organizations are putting out changes to software every day and many times a day. So that's normal. So from that perspective, the agile movement over the last 23 years has been a success because it completely changed the industry habit on frequency of delivering changes into production environments. But what it only incrementally improved was the success rate of software projects. And over half of software projects are still largely failures. And you have to define failure as looking at it from an investor standpoint. At the beginning of a software project or software initiative, even if the software has been around for a long time, at some point, the board of directors or some executive leader is going to say, you know what, let's invest a certain amount, a certain significant amount in the software package that we have, the custom software that we have, in order to achieve some strategic goal. And so that amount of money is invested. Well, if the strategic goal doesn't happen, then there is regret that the money was invested because that investment did not yield the return on investment that was expected. That is a business failure, regardless of the plans and on time, on budget. Most of the time, all of these are way behind budget. Way behind schedule, over budget. And at some point, when the software executive who kind of made the call said, man, if I'd have known this was going to happen, I would not have done it. Well, that's a failure. So I wanted to review Agile because in today's world, there's hand waving about Agile as if it's old and as if everybody knows it and as if everybody does it, but that's just not the case. And so I want to highlight a few pieces. And this is straight from agilemanifesto.org. This is literally just a screenshot from agilemanifesto.org. And there's four values. And this is interesting, but the second one, working software over comprehensive documentation. Well, the important part is that there's working software. There's working software frequently. Customer collaboration, responding to change. Those things are kind of accepted in spirit, but some of the principles behind the Agile Manifesto have kind of been forgotten. And so there's 12 principles. These are the first six. There's 12 principles behind the Agile Manifesto. And the first one literally is early and continuous delivery of valuable software. And so the software has to be valuable, not just a change, but it actually has to be valuable and delivering continuously. Okay. Um, if we go down to the third one, delivering working software frequently from a couple weeks to a couple of months. Well, now that was 2001. Now really it's deliver software continuously, frequently daily. or weekly. That's kind of the frequency. And then the next one has largely been forgotten. Business people and developers must work together daily throughout the project. So if you are running a software organization, um, the collective industry wisdom and the Scrum methodology has kind of created this role called product owner or product manager. And and then there's software product managers and software product owners. And there's been this role, this intermediary role that's popped up that's at odds with this agile principle. Because this agile principle is business people and developers working together daily throughout the project. Well, the business people are operating their business units, and maybe, monthly there's some people that come and work together with the developers. But in most organizations, and we consult with a lot of organizations, um, this, by the way, all taken aside, small companies small companies do this really well because everybody knows everybody's name and there's not a whole lot of layers. But then as you get to mid-size and larger organizations, there always ends up being a person who's a go-between, who is not a developer, who doesn't really know how to read the code or even look at the code to see what the software is doing or make decisions about how the code should be structured, or even the data in the database. And they're also not in the business unit helping that business unit operate. They're a go-between. And that that also was present in the 90s, and that didn't yield very good results. And the Standish Group has some findings about this go-between, and there's multiple titles for them. Sometimes a go-between is called a project manager, in certain cases. And it's not that any of these roles are not good. It's if you have a role called something that is not developer and is not directly in that business unit operating, doing what that business unit does, and that you've set up that role to be the go-between, then you're not getting the benefit from this principle, which is business people and developers working together daily throughout the project. And because of that, you're going to have the game of telephone, and um, this concept of requirements popping up, which is a holdover from the 90s. This concept of requirements where we translate our strategy into a set of software features where we say, um, or the go-between would say, okay, so based on what you need, then we're going to have some set of software features, and I want you to agree that these are the software features we're going to build for you. The business unit says, okay, yeah, sounds good to me. And then the go-between role goes to the developers and says, all right, here's a set of features we need to build. And we're basically codifying some guesses into the definition of success for the developers. But um, they are guesses. They're absolutely guesses. And through some survey studies done, I think it was put out in 2018 by Puppet Labs, State of DevOps report, um, only about a third of those guesses end up being right on average. Another third of those guesses end up not really making a difference for the business, and about a third of those guesses just go in the wrong direction and they need to be backed out quickly. So I want to highlight this principle: business people and developers working together daily throughout the project as one of the forgotten agile principles that needs to be brought forward, because this makes sure that there's not a game of telephone. And I mean real business people who are responsible for like literally working in that business unit daily. Okay. Um, all right. And the sixth one, the most efficient, effective method of conveying information to and within a team is face-to-face conversation. So there's so much communication these days that that is over email and Slack channels or different chat text mediums. Creating long documents has kind of gone by the wayside, but there's a whole lot of text chat that's going on. And video calls are getting more popular. That's great. But because video calls are getting more popular, there's a lot more remote work where we think that we're capturing all of the face-to-face interaction, and we're not. All we're doing is kind of staring at each other. But if you remember, if you're the Agile Manifesto, basically um, uh, interpreted this business people and developers working together daily throughout the project as co-located. And now most of the software work is not co-located. It's over video call, and we're a lot more work from home, work from uh, different locations, and so there's a lot less huddling around a whiteboard drawing together. And so as you're running a software group, think about these types of interactions, and you need to make up for it in some form or fashion. So I'm going to actually uh, change change what I'm sharing briefly, if I can, to to a mode where I can draw. And I'm on the slide, and I'm just going to pretend that this is a whiteboard. And actually, I'm going to go down to PowerPoint, and I'm going to be a pen. If I go back here. All right, so all right. So if I'm at a whiteboard and I'm drawing, and of course I don't draw very well, but this would be the same if I'm on a whiteboard, it's gonna be the same, scribbly, and um, I might have some components, and I'm using a Wacom pen and tablet connected to my computer so that I can draw something, so that I can simulate, something on a whiteboard. And if multiple people have it, there's these tools that you can use that are gonna, make up for the inability to be physically at a whiteboard next to each other. And so you need to think about these things. All right, so I'm gonna erase that. Let's go to the second six of the principles of the Agile Manifesto. Simplicity, the art of maximizing the amount of work not done, is essential. This is another forgotten principle of the Agile Manifesto. And by the way, I'm going back to basics here. If you are running a software organization, or if you're planning on running a software organization, the blocking and tackling has to be solid first. Just like if you're coaching a sports team, you don't start out with trick plays and Hail Mary passes down. You start out with the basics. Every player on your team has to be doing the basics really, really well, second nature, so that then you can have a really clever playbook. And so these are the basics. Simplifying, uh, there needs to be regular discussions about what we have in our list of things to do, our backlog, and regular discussions about which ones, you know what, might not be necessary. And this is where having this go between the business and the software developers is pretty dangerous, because if a backlog is defined as success, we basically are eliminating the ability to identify work that doesn't need to be done. Okay. So here's another one that has kind of been forgotten over time. Then I'm going to highlight in following slides the ninth principle: continuous attention to technical excellence and good design enhances agility. Continuous attention to technical excellence. Okay. And then um, and of course all the rest are important, but I just want to highlight a few of these. And of course, by the way, number seven, working software is the primary measure of progress. If you're not producing a scorecard as the format of a status report that puts down as a metric, a measure for working software and how much working software has been delivered, then you're not really giving good status. And I'm not talking about how many features are delivered. I'm talking about working software as in we've accomplished goals. Okay. All right. Now let's fast forward a little bit. Agile had a good run. 2001, does say 2011, 12, the whole industry was talking and debating about Agile and how to use it in the best way, how to implement it, and extreme programming discussions, Scrum discussions, or Agile user groups, Agile conferences. And then this DevOps word came up, and a lot of people started talking about DevOps. Now, the person who kind of coined the term DevOps, his name is Damon Edwards. He has a YouTube video you can search for called the short history of DevOps, and um, he at the time was working as a systems engineer or a sysadmin, and he was looking for a way to basically take all of the gains of Agile and put them towards system administration. And of course, at the time, around 2009, 2010, um, the cloud services were very early and they weren't completely automated. And VMware was kind of king in the data center with virtual machines. And while it was possible, it was still really, really hard to automate infrastructure and be really agile about system administration. So this DevOps movement started by the discussion of how to take the Agile Manifesto and apply it not just to software, but to system administration. But of course, the name Agile System Administration doesn't sound too, it doesn't roll off your tongue. And so through discussion, some others suggested, development operations or DevOps and that kind of stuck. But since 2009 and 10 on to 2024, what we've seen is the technical capabilities of what started in the Agile software community applied to system administration. Whereas now every change to the servers and infrastructure is also considered a change, is also considered a feature, and can also just live on the backlog with any other software feature, as opposed to having to set up, server racks one time and not change them for a long time. We can spin up and down server resources pretty much at will now, and we can apply the same thinking and the same techniques of with agile software development in agile system administration. So so I invite you to kind of think of it that way. Now, I want to talk about 5 pillars that you have to do really well when leading a software team effectively. And these are the 5 pillars of the clear measure way, and they are: you have to create clarity, you have to establish quality, you have to achieve stability, you have to then increase speed constantly, and you have to optimize the team constantly. And you need to keep on evaluating these 5 and strengthening these 5. And you have to start with clarity. Clarity is an alignment on what strategy we're going after, how we're going to accomplish that strategy, and drive that down to every member of the software organization. Because again, if you have a game of telephone, or if you have a break in communication, a break in alignment, then everyone's not pulling in the same direction. But I want to camp out for the next portion of this webinar. I want to camp out on establishing quality, because that can sink a software organization. It can absolutely sink a software organization. And you need a really clear plan for how you are going to establish quality with every software project you're running, every software system that you have, and protect quality. You have to establish it and you have to maintain it and protect it. Because once you start to lose quality, that is a very, very slippery slope and it just compounds and snowballs and gets worse and worse and worse. And then you're in a situation where I mean, it's a monumental effort to recover. So, so after creating clarity on what we're doing and why we're doing it and where the finish line is and what direction we need to go, the next step is to establish quality and protect it. So W. Edwards Deming was instrumental in the quality movement in manufacturing, and one of his famous quotes is, "If you can't describe your plan, you don't know what you're doing." And I like his blunt nature. He also has a Deming chain reaction, and this is part of this is directly out of his book, Out of the Crisis. And it starts with doing something to improve quality. And again, this came from manufacturing, but it's the same with software engineering. You do something to improve quality, and then costs decrease because of less rework, fewer mistakes, and then productivity improves because all of the team's capacity is going towards pushing the project forward instead of rework and fixing mistakes. And so your productivity improves. Then good things happen in your business. You capture more market share, maybe lower price, you can do more things. And then as a result, your company stays in business and your company stays in business and then provides more jobs and then you can start the chain reaction over again. You can figure out something to improve quality yet again and do this chain reaction. Now I want to talk about not the um not this cycle, but a vicious cycle that is the opposite that we are guarding against. And if we don't intentionally guard against it, it will eat our lunch as software leaders. So there's a survey that's published in Computer World, and it's called the Software Engineering Meeting Benchmark Report. And it found that most engineers spend nearly a third of their week in meetings. And um, if you break it down, it found that about 20 hours were spent in focus time, actually working, concentrating. And then 11 hours were spent in meetings, and then 6 hours in kind of fragmented work time, not really focused, and maybe checking email or doing other things. Now you notice that only is 37 hours, so there's a few hours that kind of just bleed away because they're so fragmented that they kind of bleed away. That was the results of the survey. So unless we do something intentional, only 20 hours a week tends to be, on average, what's spent actually focused on really working to do what we think we have them on payroll to do. All right, let's break that down a little bit more. Um, if we have fragmented work time and if we have meetings and then we have focus time through um, other quality trends, on average, half of a developer's work time tends to be fixing bugs, fixing problems, as opposed to developing new changes, developing new features. And we kind of get that, general half and half from work from Capers Jones and other surveys, but that's that's been corroborated a whole lot. So if you take focused debugging and focused development, and then your fragmented work time and then meetings, you get um, you get kind of this 27% of the work week on focused development. So let's just simplify that down to 25%. A quarter of the work week is what you think that one of your developers is working on the entire work week. And obviously that's kind of out of alignment. So So why is this happening? What's causing, besides the meetings problem and the fragmented work problem, why is half of the rest of the time going towards problems? And of course, we need to have the conversation about how to stop that and reallocate. So let's look at this. There's four different cycles, and I'm simplifying. There's four different cycles in a software team. You have you have making individual code changes on the developer's workstation, and many cycles per hour. Then, when the code is shared with the team, a pull request, then we jump out to the next cycle, which is at the team level, and we have a build and pull in the pull request, do a build, produce a new release candidate for the software application, and we have a new version, and so we push that out to the next level, which is typically product team or someone in the business unit that we're serving, and they look at it and run it through its paces and check to make sure that they're happy with it. And then once they're happy, it's cleared for production release, and then we push it out to production where some customers start using it, or perhaps the actual people in the business unit, and they're using it. So we have these various cycles. And going all the way back to the 70s, it's kind of proven over and over again that a defect that escapes out to the actual user of the software are an order of magnitude at least more expensive to remove. And some surveys have found two orders of magnitude more expensive to remove. But I think anyone who's been in software for a while understands that if a defect jumps from one of these cycles to the next cycle outward, it's significant. For example, if there was a problem in the software and I, as the developer, find it on my workstation and fix it, yeah, I can, I fix tons of these things, in minutes. But once something escapes and it's pushed out as a pull request to the team, and some other people are looking at it, well, in order to fix it, well, now even for simple things, I'm at least an hour. And if the team sends, internally to the business unit that it's serving a release candidate to look at, well, and then the problem is caught there. I've got to send it back. It's multiple hours, maybe multiple days. And then if it gets pushed out to production and the users are using it and the bug is found there, then again, we're at days, or maybe, now we're into the weeks. So um, that just tends to happen if a defect escapes out one of these bands of process. Now, from studies of over 19,000 software projects and research compiled by Capers-Jones, we know that only 40% of defects are actual problems with the code. There's problems with server configurations, there's problems with data, there's problems with analysis, where a decision for how something was supposed to work that was then faithfully coded, that could be the defect. And also 9% of the time that we fix a defect, we introduce a new and different defect. And this is where the vicious cycle comes in, of fixing defects, and then we accidentally break something in a seemingly different part of the software. But this general environment makes it hugely costly to allow defects out. So the engineering practices that we employ are very, very important, because um, because how to establish quality is a project in and of itself. Because if we don't establish quality, we will get sucked into this vicious cycle of rework, and then all of our team's time is going to be sucked into fixing problems, and a smaller and smaller and smaller piece of the weekly pie will be spent on getting new features down the road, and then the software project slows and slows and slows, and then weeks go by and months go by, and we're not getting anything done. And then the executive that allocated all of this budget for the software project, they're asking, where is this going? And all we can talk about is how hard our people are working and the long hours they're working and coming in nights and weekends. And no doubt, yeah, they're spending extra time, but they're just spending extra time fixing problems. They're not actually getting more done. Okay. And that's why it's so important that you are equipped as an effective software leader. We do have a resource, a booklet called the Software Leaders Handbook, and you can go to resources.clearmeasure.com and you can find that. It's a free download on the website. I invite you to go and look at that. It's got some key principles for success. One of the ones I want to highlight is a system for visibility into where your bottlenecks are. So um, this should be familiar for quite a few of you, but this is a Kanban style work tracking board, and it has 9 stages. It has 9 columns. There's a lot of work tracking systems out there that will visualize work as a series of columns and has named stages at the top of the column, and that's become fairly common. The problem is that all of these systems kind of give you a default that might be like not started, and then you might have in progress, and then you might have done, or maybe you have one more. And it's very it's very, very high level in that regard. So um, basically, not started is here's the stuff left to do. And then in progress means we've said that we've started it, and then done is that's done. But it doesn't give you any insight into why it's taking so long. What do you mean in progress? In progress where? And that's the question. If we say that our team is working on something, what part of it are they working on? And if it's being worked on for a long time, where is it stuck? What activity is taking so long? So, decades ago, there was a concept that was created called the software development lifecycle, and largely the agile movement kind of started, unfortunately, questioning everything. And so the software development lifecycle stages kind of got some hand wave treatment, and we've gotten a little bit less disciplined on tracking which activity that we're currently doing for a particular software feature. Um, and so that concept is absolutely critical so that you understand what stage a particular feature is in. And notice that development is the center column. So if you take the process like a sandwich and fold it onto each other, the things that happen before development or before coding are design decisions. And the things that happen after the development column or the column where the code is written, those are validation or testing or verification activities. And the what makes this Kanban style and an implementation of the Agile Manifesto is that you move one software change through independently of others, one at a time, single piece flow, as opposed to batching dozens together and moving them through. So if it's a simple text change, it may fly through this board really, really fast. Or if it's a more significant software capability, it may, take longer. But I want to highlight the 4 design decisions ahead of the column where you write the code. And even if you want to call them different things, that really doesn't matter. But you need to make 4 design decisions. You need to define the concept. Why are we doing something? And defining why we're doing something equips and empowers everyone in the development team to question why we're doing it, because we might be able to simplify something and maximize the amount of work not done. We might come up with an idea that makes it absolutely unnecessary to do that particular feature that was ideated, that was thought up. If we can make some other change, maybe we can make a process change, and then we can accomplish the goal without even having to deliver the software. So things in the concept definition column, those cards, those issues, whatever you want to call them, those are um, business capabilities. All right. And then as you flesh out the concept, you kind of might split out, some software behaviors or software features as you move it to user experience design. But if you can make a much smaller change and accomplish the concept, well, now you have a much smaller software change to flow through. Or if you can make a business process adjustment, then then that can flow through just by, testing that the business process can be satisfied with the existing behavior of the system. But the next stage is user experience design. That is where we decide how a person is going to use a change in the software system. If it's a change to a screen, we do the wireframes in that column. Then we move on to technical design, and that is design patterns, libraries, architectural changes, perhaps. And this is where we break it down into individual development tasks and decompose into those tasks. And then the next step is test design. Armed with all of these previous design decisions, we determine how we're going to test this software behavior once it's actually working. And it also gives us a chance to define the concept of done. Um, what 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 workflows are in, what workflows are out for this particular scope change. And then, of course, goes through coding. And then functional validation is at the team level. User experience validation is typically at the business level. And then release validation is uh, server and cloud configuration, making sure we're ready to push out to the customers uh, and making sure that we're ready to have users actually start using it. So this is an important tool for knowing where things are in the process because something is going to get stuck. And if you don't have a visualization, if you don't have a tool that allows you to quickly see that, hey, we have a backlog or we have a bottleneck in user experience design, then you may be asking, you may be asking the people who are coding, writing the code, hey, why isn't this flowing? And the answer is, well, we really can't write any code for it yet because we're still haggling on how it should look and what fields are important and what data fields are coming from outside systems versus, it tends, um, bottlenecks tend not to be in actually writing code. Bottlenecks tend to be in time spent making decisions. And so a tool like this helps you pull out the design decisions from the status where we're writing code, and so that you can see and reason about where all the time's going. All right, I'm going to gloss over automated DevOps because we've done so many webinars on that, but it is important that you have the technical capability to make a change and do a git, commit, and push, and actually have a release candidate in production very, very quickly, same day. Every system is different. We hear of those online companies who are making, dozens and dozens of production pushes per hour, but those are largely e-commerce systems and or the big social media companies where, yeah, across many pieces of software, but for a single software application, um, I'm not talking about systems with many, many applications, but for a single software application, you should feel good about yourself if you can fix a spelling error in an hour. If you can, find where to make the small little change and go through all of the stages, validation, release candidate creation, running all your automated tests and deploying through your series of environments to production. If you can go through that flow um, automatically in 1 hour, you should feel pretty good about yourself. And if you can't, then you need some work on your DevOps automation. Let's come back to the slice of the pie for our work week. We talked about knowing where the time is going. We talked about quality, but let's kind of go through a scenario. On average, unless you've really thought through, unless you've done things intentionally to not kind of be industry normal, then this is what's under the covers and probably mostly your reality. Focus development time is 27%. Focus debugging, fixing problems, 27%, then 30% meetings, and then 16% fragmented time. Now, if we eliminate defects or severely reduce defects to only 3%, and we establish quality, we have just doubled our productivity. 100% improvement. Doubling productivity is 100% improvement by establishing quality. Okay. Focus development up to 51%, focus debugging, and that hasn't even addressed the meetings or the fragmented work time. Okay. Um, Now, if we go forward and intentionally cut down meetings or cut that in half, now we have improved productivity 150% from start. So we can triple productivity, triple current productivity by making these two changes, these two focuses. And unless you've intentionally looked at the calendars of the developers and how much time has been pulled away from focus time on the software and the meetings and other things, then just I would expect that you're gonna not like it when you finally do analyze the amount of time, and it's going to be more than you think is necessary. And people in people in management positions, meeting is the work of management. But for software engineers, scheduled meetings are not the work. The work is software. And collaboration, uh, if you think that collaboration happens in scheduled meetings, then you can be right, but more efficient collaboration happens when people are just working together. Where something is not scheduled, all of them are assigned to the same tasks and they're just working together. Meetings tend to happen when we need to get people to work together who have not been structurally organized in the way that they should to work together. So the agile principle that calls out business people and developers working together on a daily basis. Well, yeah, they need to work together on a daily basis, but if we haven't set up a structure so that they are working together on a daily basis, well, now we end up scheduling time to get them to talk to each other. And now there's scheduled meetings on the calendars. Okay. So instead, we need to get someone from actual business operations and get them and get them and the developers joined together, which really means get our development team embedded with the business organization that the system is serving. All right. Um, there's another resource that we have on our website, and it's a guide, and it goes through moving from chaos to order, and it um, talks about unfortunately the bad things that happen when you don't create clarity, when you don't establish quality, when you don't achieve stability, when you don't increase speed, and when you don't optimize and lead the team. And so, as we come to a close on today's webinar, hopefully equipping you to be an absolutely outstanding software engineering leader. I want to invite you to use all of the resources around the Clear Measure way and the tools, the assessment tool, uh, the scorecard template, the team alignment template, as well as the different guides that we have on our website. And I want to review the 5 pillars that every effective software leader needs to keep in mind. These are the 5 things that you need to be really, really good at. You need to be good at creating clarity on what your team is actually doing and why. You want to establish, you want to be good about establishing quality and protecting it. You want to be good about achieving stability, which is not a topic of today, but again, if you're fixing problems in production, well, your team's not developing features. And then you want to be good at increasing speed, which we'll do some more webinars going deep into that one. And you want to be good at optimizing the team, which we'll do future webinars as well. Probably in the next 2 months, it'll come to print. My next book, that's called The 5 Pillars. And the title is The 5 Pillars Leadership for Effective Custom Software. And just by virtue of you coming to a webinar with the present title, you have what it takes to oversee a software project. This book is for you. And I know we do have some individual software developers on the webinar as well. This book is for your boss. Now you want to read it too, but this book is for people who are leading or have aspirations to lead software groups. And it goes deep into all of them. And we'll have some giveaways and offers around this. And if you are interested in an early electronic review copy of the manuscript, then you can send me an email or you can send a note to my webinar assistant in the chat and let yourself be known, and we can put you on the list. This should be coming out in a couple of months. We're getting to the tail end, and it'll be a nice, beautiful hardback book with glossy cover, and really good paper quality on the inside, and lots of great information for how to be an effective software leader. If this was helpful directly today and you want to take the immediate next step, the next step would be going to clearmeasure.com/assessment and doing a self-assessment of your software team, and it will lead you through a list of easy to understand questions so that you can get a sense of the hot spots in your current team from a capability perspective so that you can know how to prioritize your improvement efforts. So go to clearmeasure.com/assessment. We put the link in the chat as well. And it's a way for you to get a quick assessment so that you can prioritize your improvement efforts. So thank you very much for your time today. And again, my email address is jeffrey@clear-measure.com. And I'd love any questions that you have. And have a great, terrific Tuesday, and God bless.